Welcome to this video. We are going to finish the no calculator portion for the 1998 AP Calc BC multiple choice. Okay, so let's dive right in. Number 18, which of the following series converge? So let's go one by one. This guy, I can already tell it diverges because, let me get a piece of paper. We can do the test for divergence. What does that say? That's the limit as n goes to infinity of n over n plus 2. This is equal to 1. Clearly, it's not equal to 0. So the series cannot converge. It's divergent. So we can cross that out. How about the next one? We have cosine of n pi over n. Okay. This one we can, draw a line here. Well, by the way, we can skip to this one first. This one we know is divergent because this is the harmonic series, or p series with p equals 1. How about this one? Well, this is cosine of n pi, so for integer values of n. So what is that? So like cosine pi, cosine 2 pi, cosine 3 pi, so on and so forth. What's cosine pi? -1. 2 pi, that would be 1. 3 pi, -1. It's alternating between, if we think of the unit circle, it's alternating between here and here. So 1, -1, -1, -1, or it starts with -1. So it'll be -1, 1, -1, 1, -1, 1. I'll alternate. So this is a alternating series, actually. They chose to write it like this, but you can write it as -1 to the n. In this case, it's the same thing, as you can see. Okay, so we can use the alternating series test where we know that, well, this guy, because remember, we can equivalently write it like this. Okay? Well, we know this is the alternating harmonic series, so we know it's convergent, but otherwise, we can, how do we show that alternating harmonic series is convergent? We use the alternating series test, which says that, well, 1 over n, so without the changing sign, has to be a decreasing series, which it is. And the limit as n goes to infinity of this guy is 0. So by the alternating series test, this guy converges. So it should be 2 only. Area of the region inside the polar curve, r is 4 sine theta. And outside the polar curve, r is 2 is given by what? Okay, so this is probably one of the trickier problems in AP Calc BC in general, area between polar curves and all that. Okay, so we need to know how these graphs look, or at least this is how I would approach it. R is 2, that's easy. That's just a circle of radius 2, something like this. Okay. How about r is 4 sine theta? I know how r is sine theta looks like a circle up here, if I remember correctly. So it'll just be something like this then. Okay. So the one centered about the origin is r is 2. The other one is 4 sine theta. Okay. So it's asking for inside this circle, outside r is 2. So it's asking for this area, actually. Okay. So how do we get that? Well, we don't actually have to solve it. We just need to set the integral. So let's peek at the limits. Because the limits should be from here to here, but I didn't draw, my drawing is not good, but there's symmetry. So technically we can integrate from here to pi over 2 probably, but they don't have something like that. So let's integrate from here to here then. We can always just, by the property of even functions, do the symmetry thing also. So what are these values of theta? These are values of theta, right? Because this is a polar curve and we're in polar coordinates. So let me draw it like this then. What are these values of theta? They should be symmetric also, okay? So we just set these two equal to each other. So it'll be 2 is 4 sine theta. or half is sine theta. Okay, so where is that? There's technically an infinite number of points, but let's just worry about from 0 to 2 pi. Okay, so theta would be, the easy one is the quadrant 1, 1. That is pi over 6. What about this one over here? That would be, well, if this symmetry, right? If this is pi over 6, this should be pi minus pi over 6, which is 5 pi over 6, okay? So those are our two thetas. So we can set up our integral as from pi over 6 to 5 pi over 6. Remember that it's area of a sector, so it'll be half r squared d theta, something like that, right? But what's r? R is, well, let's get the area of the outer circle first and subtract it from the area of the inner. Okay, so hopefully you can see that, because if I get the area from the outer, it'll be over here, but it includes some of this, right? But then we can subtract the area of the inner to just get the outside over here. Hopefully you can see that. So let's write it as two integrals, actually. So minus half integral. This just makes more sense to me, so we can combine things later. Okay, so the outer circle I said was 4 sine theta squared. The inner circle is just r is 2. Okay, so actually we can even combine now these two integrals into one. So I'm just going to do a few steps in one. Hopefully you'll be able to see it. Okay, so it would be 16 sine squared minus 4 d theta. Okay, and that looks like choice D. Okay, so hopefully this makes sense. So this is one of the tougher problems in BC calculus. Okay. When x is 8, the rate at which cube root x is increasing is 1 over k times the rate at which x is increasing. What is the value of k? Okay, so let's write out in a formula what this problem is saying. And don't recall if I did this in the AB video. But, okay. When x is 8, the rate at which this guy is increasing, so that should signal derivative. So the derivative with respect to x of x to the 1/3 power, cube root x is the same thing as x to the 1/3, okay, is the rate at which this guy is increasing is, so equal sign, 1 over k times the rate at which x is increasing. So that's technically like this. I can even write that. This clearly 1, okay? So let's solve for k then in this equation, okay? So this would be 1/3 x to the negative 2/3 is equal to 1 over k. Okay, so how can we solve for k here? Well, actually, I can rewrite this as 1 over 3x to the 2/3. We move it to the bottom. The negative exponent is 1 over k. Okay, so we can say, oh, well, actually, we can even plug in when x is 8. So let's plug in x is 8 over here. That would be 1 over 3 times 8 squared is, okay, 8 to the 1/3 power is 2. 2 squared is 4. So hopefully you can see that k should be 12. This is a 4, okay? K should be 12. Length of the path described by the parametric equations, x is t cubed over 3, y is t squared over 2, where t is between 0 and 1 is given by what? This is arc length, so it should be integral from 0 to 1, square root of dx dt squared plus dy dt squared dt. So what's dx dt? That is just t squared. What's dy dt? That's just t. So both of those are still squared. So you should have Good notation, don't get confused like I almost just did. Dx dt, that is t squared, but we still have this squared. And then dy dt, my handwriting's not great in this video. dy dt, that's just t, but we have to square that stuff from this squared, okay? So it should be integral from 0 to 1, t to the fourth plus t squared dt. We have this limit as b goes to infinity. Integral from 1 to b dx over x to the p is finite. Then which of the following must be true? This looks like it's just using the integral test to test for convergence or divergence. That's what I'm thinking, because this, if we write it in the other notation, is the integral from 1 to infinity of 1 over x to the p dx. Okay, so we can write a similar series, not a continuous function, but if it's only discrete values. So this would be like n goes from 1 to infinity, 1 over n to the p. Okay, this is the equivalent, not equivalent, corresponding infinite series. They're definitely not equivalent, okay? Since this guy is finite, meaning it converges, then this guy also converges by the integral test, okay? So does one of the answers say that? I think that's A, right? That's the answer, good. Okay, as simple as that. Let f be a function defined and continuous, maybe that's key, on the closed interval a to b if f has a relative max at c, and c is between a and b, which the following statements must be true. Okay, I'm not sure if I did this in A-B exam, but let me do it again because I don't remember, and let me show you my thought process. Okay, so defined and continuous. This is key. It doesn't say differentiable though. So that's probably key to this problem. We don't know if it's differentiable. Remember, if something's differentiable within an interval, it's automatically continuous within that same interval. But it doesn't work the other way around. If it's something that's continuous, it's not necessarily mean that it's differentiable, okay? So it says f has a relative max at c is between a and b, which of the following statements must be true. F prime of c exists. This, I know, cannot be true because we can think of a counterexample of like absolute value of x, but negative absolute value of x, okay? We see that there is a relative max here, but it's not differentiable at that point because it's sharp turn, okay? So this, now notice even the choices 2 and 3, it prefaces if f prime exists, okay? So if f prime exists, then f prime of c is equal to 0. Is that true? Yes, because if it's differentiable, then since it says there's a relative max, now it says it's differentiable, then yes, this has to be true. Okay? Now if f double prime exists, okay, then f double prime c has to be less than or equal to 0. It has to be concave down. Is that true? This should be true because if it's a max, then it's concave down. So this is true. So 2 and 3. Yes, okay, good, got that right. We move on. Okay. We have the slope field. We want to find a solution. Okay, so how can we solve this? So we know that there's multiple ways to solve it. You can start by like seeing whether these functions fit the slope fields, okay? Or you can pick like a point, for example, at 0, 0, we see the slope field is this 0, it's horizontal. So dy dx should be 0, so we can eliminate some choices maybe just by that. If at 0, 0, dy dx is 0. This would not be true if x is 0, then dy dx is 1, right? ln of 0, it'll be undefined. Actually, is it horizontal or undefined there? It's not very clear to me. So maybe let's leave that alone first, but actually, ln y. Yeah, this one actually, you're not sure if it's horizontal or vertical actually. So this we cannot quite eliminate by that logic. This, excuse me, we cannot eliminate either. This, if it's 0, 0, then it'll be flat, so that might be fine, and this might be fine. So we eliminate one choice at least, okay? So let's move on to checking some other points, maybe, okay? Like when, so this one, it doesn't depend on x. Okay, so it should be no matter what value of x, is either the horizontal or the vertical should be the same. Which one is it off the top of my head right now? So when y changes, for the same x doesn't change, y changes, the slope field should change. So when y doesn't change, the slope field should be the same, which it isn't. Okay? So we can cross that out over here. And similarly, by this logic, when x changes, the slope field changes. Okay, but when x doesn't change, so like this, the slope field should not change, but it does. So we can eliminate that also. So now we have 2 left, okay? So which one would it be? Well, it doesn't quite look like this one, because if x and y are both negative in this quadrant, the slope field should be positive, which that's not the case. So by process of elimination, 24 is C. Okay, that's one way to do this. Not the quickest way. There might be a quick way, but that's how I did it right now, okay? We have this improper integral from 0 to infinity, x squared e to the minus x cubed dx. Okay, so let's just solve this with substitution. We have u be minus x cubed. Du would be minus 3x squared dx. So our integral becomes, let's worry about our limits after. We have x squared dx, which is du over minus 3, so minus 1/3 du, and then we have e to the u. Okay, limits of integration. When x is 0, u is 0. When x is approaching infinity, u approaches negative infinity. So we can even flip the limits and get rid of the negative sign. Okay, this is just 1/3 e to u, evaluate from negative infinity to 0. So it's 1/3. What happens to e as u goes to negative infinity? It goes to 0. And then we plug in the this should have been the other way around. Upper limit first, minus lower limit. Okay, e to 0 is 1, minus as u goes to negative infinity, e goes to 0. Okay, so it should just be 1/3. Okay, now here we have this, this has been a while since I've done this, logistic differential equation. Population P satisfies this differential equation, logistic differential equation, where the initial population P of 0 is 3,000, and T is the time in years. What is the limit as T approaches infinity? P of T. So if I remember correctly, usually we like this number to be a 1, so let's factor out that 1. So dp dt is, so if we factor out the 2, did I say factor out 1 earlier? I'm not sure. So we want to factor out a 2 to make this 1. So it'll be 1 minus, well, when we factor out a 2 from here, what happens? It'll be P over 10,000. Okay, you can check by putting the 2 back in, we should get this. So this term would be for the logistic curve, it looks something like this, right? This value is this, if I remember correctly. So it should be 10,000. Yes, that looks right. Good. Okay, so as simple as that. You just have to know the components of the logistic differential equation. Okay, if n goes from 0 to infinity, a n x to n is a Taylor series that converges to f of x for all real x. F prime of x is equal to what? I mean, f prime of 1 is equal to what? Well, if this is convergent to f, we can, remember, we can differentiate power series. So we can just differentiate this term. Okay, so that would just be, well, f prime would be, we just differentiate with respect to x. So we differentiate this x to n. So it'll become summation of a n times x to the n minus 1. So we evaluate this, x is equal to 1. What do we get? So n goes from 0 to infinity still, okay? So we get summation as n goes from 0 to infinity, n times a sub n, I believe. 27 is d, yes. Okay, so we just differentiated the term with x. So we just do the power rule. It'll be n x to n minus 1. That's what I did over here, okay? So then if we plug in x is equal to 1, 1 to some power is just 1, as long as it's not infinity. So this is what we get, okay? This one, limit as x goes to 1, and going from 1 to x e to t squared dt over x squared minus 1 is, well, when we plug in x is 1, we get 0 on top because going from 1 to 1 is 0, okay? And then we get 1 minus 1, which is 0 on the bottom. So 0 over 0 is indeterminate. Let's use L'Hopital's rule. So what happens when we differentiate the top? It'll just be e to the x squared by fundamental theorem of calculus. The bottom, we get 2x. Okay, so now when we plug in x as 1, we get e over 2. Okay, and is that it for the no calculate portion? It is. Okay, cool. So hopefully this was helpful. If you do have any questions, feel free to leave it in the comments. Please like this video if it was helpful in any way, and please subscribe to the channel so that you can get notified for when I post the graphing calculator required portion of this exam.